Welcome to AI Podcast. Today we're digging into CitySim from EMNLP 2025, a project by Nicolas Bougie and Narimawa Watanabe at Woven by Toyota.
Set the stage for us. What's the short version?
Short version is this. CitySim uses large language models to run a whole city of virtual people. Each agent has a persona, needs, beliefs about places, long-term goals, and memories. They plan their day with a value-driven scheduler, not just rigid rules, and the resulting behavior lines up more closely with real human patterns than earlier systems.
So it's not just SimCity with prettier graphics. What's actually new under the hood?
Right. The novelty is in the cognitive plumbing. Think of each agent as a commuter with a diary and a mental map. The diary is memory. There's a timeline of what happened, a daily reflection that summarizes what mattered, and a spatial memory that stores beliefs about places like price, atmosphere, satisfaction, and convenience.
A personal Yelp in their head.
Exactly. And those beliefs don't just flip overnight. They're smoothed as new experiences come in, which keeps the agent from overreacting to a single bad latte.
You mentioned needs and goals. How do those drive the day?
The agents track 4 basic needs: hunger, energy, safety, and social connection. Picture a thermostat for each one. As the day unfolds, those levels change, and when something drops too low, it nudges the plan. On top of that, agents set longer-term goals, so they don't just react in the moment, they also try to improve their routine over days and weeks.
And the planning part, value-driven scheduling, what does that look like in practice?
It's like writing your calendar each morning. First put in the mandatory blocks, like work or school. Then, for free time, the agent generates a few candidate activities and picks the one that best balances its needs, habits, and current context. So if hunger is rising and there's an appealing cafe nearby, lunch might win. If social needs are low but energy is dropping, maybe a quiet break is chosen instead.
How do they pick where to go and how to get there?
Place choice uses a gravity-style model. Imagine popular places pulling you in like magnets, but distance weakens the pull. The twist is that each agent's beliefs about a place boost or dampen that pull. For transportation, they reason about options like walking, biking, taking a car, a bus, or a train, and pick what fits the situation.
Do these agents also talk to each other?
They do. When people are in the same place or when someone feels socially low, the system kickstarts conversations. It keeps track of things like familiarity, trust, and affinity, so relationships strengthen or weaken over time.
All right, how did the authors show this is more than a neat idea?
They ran a city-scale simulation centered on Tokyo with 1,000 agents by default. Then they checked realism on a few fronts. First, macro time use. They compared the share of day spent on categories like work, commuting, housework, and sleep to Japan's National Time Use Survey. The simulated distributions closely tracked the survey.
That's a strong sanity check. What about individual behavior?
They did pairwise comparisons of daily routines. They normalized the format of the outputs to avoid style biases, then used GPT-4 as a judge to decide which agent's day looked more natural, coherent, and plausible. CitySim won more head-to-head matchups than the baselines, which included well-known agent frameworks.
Using an LLM to judge an LLM-based system can raise eyebrows, right?
Right. And the authors acknowledge that using a model as evaluator can introduce shared biases. It's a useful signal, but it doesn't replace human ratings.
What about how people move around the city?
They compared travel patterns against a proprietary mobility dataset. CitySim captured the timing and size of commute peaks on weekdays and the different weekend rhythms more consistently than competing systems. Some baselines produced rigid spikes or smeared-out patterns. CitySims were more lifelike.
And the popularity of places. Can this thing predict which cafe or mall gets busy?
They tried exactly that in Shibuya. Ground truth came from Google Maps ratings as a proxy for popularity. The simulated visit counts showed positive rank alignment with real-world popularity. They also noted a bias. Agents tended to overfavor well-known or branded places, which inflated visits to famous spots.
Makes sense. If your mental map has stronger beliefs about a landmark store, you'll go there more often.
Exactly. The belief-enhanced gravity model can amplify fame.
You mentioned well-being too. How does a CitySim estimate something that personal?
They matched agents' personas to a survey of about 1,200 people in Japan, simulated several weeks, and had the agents answer the same well-being questions from their memory. As a classifier, a standard gradient-boosted model trained on the real data still scored highest. CitySim came in behind that, but ahead of other agent systems. The takeaway is that simulated life can provide useful signals, though it doesn't beat strong supervised learning on the real labels.
And crowd density?
They built heat maps of simulated foot traffic across Shibuya and compared them with smartphone location estimates. The hotspots lined up around transit hubs and major shopping streets. The model tended to underestimate footfall in small side streets, likely due to that popularity bias we talked about.
All right, let's talk caveats. Where does CitySim stumble?
A few areas. Some evaluations rely on non-public datasets, which can make reproduction hard. The system inherits cultural and socio-economic biases from the underlying models, and the beliefs for lesser-known places can be shaky, leading to occasional hallucinated appraisals. Also, with so many interacting modules, it's tricky to isolate exactly which component drives each emergent behavior, though they include ablations in the appendix to probe that. And as we said, using an LLM judge is informative but not definitive.
Do they say anything about scale?
The main experiments use 1,000 agents in Tokyo. The paper also argues that the framework is scalable and discusses modeling tens of thousands of agents, but the detailed evaluations we just covered focus on that 1,000-agent setting.
If I'm an urban planner, how might I actually use this?
Think of it as a safe sandbox. You could test what happens to lunchtime flows if a new food hall opens near a station, or how a festival shifts weekend crowding. Because the agents have needs, beliefs, and habits, they respond in ways that feel more human than simple rule-based scripts.
And if I'm a data scientist listening, what should I watch for?
3 things. First, evaluation. Bring human raters into the loop, not just LLM judges. Second, data openness. Even partial releases or benchmark tasks would help the community verify claims. Third, context. Weather, disruptions, and accessibility all shape city life. Folding those in would likely reduce some of the biases we saw, like the side street underestimation.
Right, and fairness checks too. If personas are grounded in surveys, we should audit whether certain groups get systematically different outcomes.
Exactly. The ethics section emphasizes consent, potential misuse, and the need to use synthetic agents to complement, not replace human stakeholders, especially in early policy exploration.
I like the mental model you gave earlier, a commuter with a diary and a mental map. It makes the approach feel concrete.
And that's the heart of CitySim. Give agents memories, beliefs, needs, and goals, let them plan like people do, and the macro patterns start to look like the city outside your window.
All right, bring it home. What's our takeaway?
CitySim shows that value-driven planning plus beliefs and memory can make LLM agents behave more like us, not just in individual moments, but across whole days. It improves time-use realism, travel rhythms, and even gives reasonable signals for place popularity, well-being, and crowd density. It's promising, and it comes with real caveats around data, bias, and evaluation.
Nicely put. That's CitySim by Nicolas Bougie and Narimawa Watanabe from Woven by Toyota. If you work in urban tech or AI agents, it's worth a careful read.
Thanks for listening to AI Podcast. Until next time.
See you next time.